Hello, future toppers. Let's make maths simple, intuitive, and fun together. So we got wholesome new session where we will understand, like, if we are not able to convert our question into like differential linear differential equation, then how we will manipulate that situation to make it into linear differential equation. So you will have a question in this form, so you know that you're clearly uh, super clear with this form that it is exactly linear differential equation. But sometimes what they will use, they will put additional y power n to it. Okay, and then they will ask you to solve this question. So how will you respond? So my idea is, do anything do anything but try to remove this y power n. Okay, and also later you have to remove this y power n. Like, if you will have, like, you have to do two things. First, you have to remove that y power n. Second, you have to make dy by dx free from any constant coefficient. Okay, so you will have problem with two situations. The situation number one is this: you have to get rid of y power n. Do anything but remove y power n. How will you remove? You will divide all side by y power n, and then you have to do something to make this element free from coefficient. Okay, I hope things are clear. Okay, now look at this. Suppose we got this situation, dy by dx equals to this. So if you'll observe, you will find out that, sir, it is dy by dx minus y. We have x, and if we will have x cube, then directly we can solve this question. But you have given this extra y power 2. So I have problem with this y square. Okay, so this thing you have to understand. Now try to pretend again. So do you think, like, we will apply, we will imagine that we are handling this question in the examination. Okay, so work out on the thought process. Okay, now, so first we will think to convert this question into variable separable method. Always your first filter should be variable separable method, then linear differential equation, then homogeneous differential equation, then you will have exact differential equation. Okay, now suppose that you have to convert this thing into variable separable method. So do you think you can put all x together and all y together? No, we cannot factorize this thing. Now, can we apply first filter of variable separable method, that is dy by dx equals to f of x, means linear function? No, we cannot do that. It's cubic 5-degree polynomial. Then we have second filter, dy by dx equals to linear by linear function. We don't have that thing. We have 5-degree polynomial on the numerator only. Then we have x dx plus or minus y dy. We don't have that x dx plus or minus y dy over here. So we have to jump onto the second criteria, that is linear variable separable method. So for variable separable method, if we have question of the form dy by dx plus y is equal to, here we want p of x, here we want q of x. This idea is important, but you know that you have extra y square which is stopping you to solve this problem. So how we will respond, try to understand. First we will make this question free from y square. How? We will divide all side by y square. Okay, so this we will have 1 by y square dy by dx minus x by y x cube. We got rid of this y square, but we have this problem that we don't want anything in the coefficient of dy by dx, but we are having 1 by y square. So how we will manage this thing? So look at this, how I will manipulate this, you have to understand. So don't you think here you want y? So what I will do, I will put z, means I will keep 1 by y as z, so that I can convert this question into the required form, y power minus 1. Now dz by dy will be minus of y power minus 2. Okay, and this is, we will differentiate with respect to x only. Okay, dz by dx, so we have dy by dx, because the function is being differentiated with respect to x, so we have to differentiate with respect to x. Okay, now look at this. Can I write, sir, dz by dx is equal to minus 1 by y 1 by y square dy by dx? Look at this, both are exactly the same, है ना? So can I convert this question into that form? So minus of dz by dx minus x z is equal to x cube. Now if it is z, we want z over here, we want free from coefficient, so we will multiply all side by minus 1, so we got this. Now in place of x you will be writing x, in place of y you will be writing z. So we have e power px dx, px, so x is x, so px will be, we will have differentiation with integration with respect to x, so e power integration x dx. Now in place of y we have to put z, so z, and then minus of x cube integration. Okay, now do this integration, so z e power x square by 2. Okay, then we have minus integration x cube e power x square by 2 dx. Okay, now look at this idea. So what we will do, look at here, we have to integrate the second component. So what I will do, I will take, not, we cannot take z because we have already introduced, so we'll take t, this thing, x square by 2, and then we will differentiate with respect to x. So we have dt by dx is equal to 2x, so we have x. Now look at this, how I am writing things. So we have z e power x square by 2 is equal to minus integration. Look at this, we have x cube into x cube, so can I write x square into x? So in place of x square can I write 2t, and then we have x dx, so in place of x dx I will be writing dt. Okay, in place of x dx we will be writing dt, and then we have e power t. I hope things are clear. Now let's do the integration. So we have z e power x square by 2, then we have minus 2 first function, integration of second function, I am doing the integration as well, minus whole integration differentiation of first function 1 e power t, e power t, so e power t. Okay, and then plus integration constant c. Let's replace t with x square by 2, so z e power x square by 2 is equal to minus 2 times x square by 2, so 2 gone, e power x square by 2 plus 2 times e power x square by 2. Okay, plus integration constant c. So this is your function. I hope the idea is clear and you guys can handle similar situations. And now you have one more thing to grasp, that is reducible to linear differential equation. Okay, so in this part you will have only one filter. Okay, so see you guys in next session of MathFlix.